Hi class, Mrs. Calvi here. We are going to be reviewing translating between tables and expressions. And you can see I have an example here. It says writing an expression. We have Riley's age, and then we also have Ashley's age. So we have to end up figuring out what the expression is between Riley's age and Ashley's age. So if you notice, when Riley is 9 years old, Ashley is 11 years old. So we're going from a smaller number to a bigger number. So that means Riley's age, which is going to be represented by the variable n, is going to be plus or multiplied by something to get to Ashley's age. So the first thing we always want to do, because we're going from a smaller number to a larger number, we're going to either check addition or multiplication first. So 9 plus what would give me 11? Well, 9 plus 2 gets me to 11. So let's see if that works out with all of them. Is 10 plus 2 equal to 12? Yes. 11 plus 2, does that equal 13? Yes. Does 12 plus 2 equal 14? And the answer is yes. So basically, that's what we had to do to figure out what Riley's age is when Ashley is a certain age, okay? So when Riley is n years old, we're going to add 2 to that to get to Ashley's age. So the expression when Riley's age is n, Ashley's age is n plus 2. So that is the expression, the algebraic expression we had to come up with, n plus 2. We had to figure out the relationship between Riley's age and Ashley's age, and that happened to have been plus 2, right? So n plus 2. So let's look at the second example. Here it says we have eggs and by the dozen. So here we're going from a larger number to a smaller number. So whenever we go from a larger to a smaller, we're either subtracting or dividing. I always start with subtracting first. Well, 12 minus what would get me to the answer of 1 here? Well, 12 minus 11 would give me 1. Let's see if that works for 24. If I take 24 and I subtract 11, would I get 2? Nope, the answer is no. So I know that my algebraic expression is not going to include subtraction. So now, because I'm going from a larger number to a smaller number, I'm going to try division. Well, 12 divided by what is going to give me 1? Well, 12 divided by 12 equals 1. So let's see if 24 divided by 12 is equal to 2. 24 divided by 12 does equal 2. 36 divided by 12, does that give me 3? Yes, it does. And 48 divided by 12, does that give me 4? And yes, it does. So now my expression, my algebraic expression, is my E for eggs divided by 12 to get how many dozen that would give me. So E divided by 12. Now remember, you can use the division symbol or you can use the fraction bar to represent division. Okay? So we're going to go through a couple more examples and we're going to work these out together. Okay, so in this example, we are going to be comparing Spike's age and Rusty's age. So I notice I'm going from a 2 to a 6. So I'm going from a smaller number to a larger number. Whenever I go from a smaller number to a larger number, I'm going to try either addition or multiplication. All right, I always start with addition first. Well, let me see. 2 plus what would get me to 6? Well, 2 plus 4 equals 6. So let's see if that works for 3 and 7. Is 3 plus 4, does that equal 7? So far, so good. 4 plus 4, does that give me 8? Yes, it does. So now it looks like I know what my expression is going to be. My age is my A, my variable A, plus 4. So in this box here where this question mark is, that's where I would put my final answer of A plus 4. That is the algebraic expression for this table. Okay, let's go ahead and try another one. Okay, so here we are comparing Ryan's age to Mia's age. And we need to write an algebraic expression that represents their age. So if you notice, I'm going from a larger number 14 to a smaller number 7. So if I'm going from a larger number to a smaller number, that means I need to either try subtraction or division. So I'm going to try subtraction or division. So when I go from a larger number to a smaller number, subtraction or division, I'm going to always start with my easier operation, which is subtraction. So 14 minus what would give me 7? So this is what I'm trying to figure out. 14 minus what number would equal 7? Well, 14 minus 7 equals 7, but we have to see if that works for the rest in my table here. So 16 minus 7. Well, it just so happens 16 minus 7 does give me 9. 18 minus 7. So 18 minus 7 does give me 11. So it looks like I figured out what my expression is. It is going to be my variable r, they used r for Ryan, minus 7 for my algebraic expression. So in this box here, you would put r minus 7. Okay? So now we're going to try a different example where it gets a little bit more difficult. So let's look at a different example. Okay, so this example definitely is a little bit more difficult, so please pay attention. So if you notice, first of all, our chart is no longer vertical. It's no longer up and down. It's horizontal. It's from left to right. So the first thing I'm going to do is I'm looking at my top numbers. I notice that my 1 is smaller than my 3. So I'm going from a smaller number to a larger number. So now I'm checking whether it's going to be addition or multiplication. I'm going to try addition first. 1 plus what gets me to 3? Well, I know that 1 plus 2 gets me to 3. So let's see if that works for my 2. If I do 2 plus 2, does that give me 5? The answer is no, okay? So I know it's not going to be addition, all right? So it's not addition. Now I'm going to try multiplication. Well, 1 times what gets me to 3? Well, 1 times 3 equals 3. Let's see if 2 times 3 is going to equal 5. Well, 2 times 3 does not equal 5. So this is the tricky part, so pay attention. Because my number, I'm going from a smaller number to a larger number, I try addition or multiplication. I tried addition, it did not work. I tried multiplication, it did not work. This is telling me that my algebraic expression is going to be 2 steps. So watch what I do next. Because addition and multiplication did not work, I'm going to find the change in my values at the bottom. So going from 3 to 5, I'm adding 2. Well, let's see if that continues. From 5 to 7, I'm adding 2. From 7 to 9, I'm adding 2. From 9 to 11, I'm adding 2. This is the tricky part. Pay attention. I'm going to take my position number, they're calling it. So that's where my variable eventually is going to be. I'm taking that, and I'm not adding the 2. I'm going to multiply by 2. So I'm going to multiply by 2. So now 1 times 2, well, that gives me 2. It doesn't give me 3 though. Well, how do I get from 2 to 3? I have to add 1 to get to 3. Let's see if this works all the way across. So 2 times 2 gives me 4. And if I add 1, do I get to my 5? I do. So let's try the next one. 3 times 2 gives me 6. If I add 1, do I get to 7? Yes, I do. 4 times 2 gives me 8. If I add 1, do I get to my 9? Yes. 5 times 2, that gives me 10, plus 1 gets me to 11. So I actually figured it out. So now I need to figure out what my algebraic expression is going to be. So here, what did I do to, these are all my n values. The 1, the 2, the 3, the 4, and the 5, those are my n values. Well, what did I do to my n? I took my n values and I multiplied it by 2. So I would not take n